Okay, so this is going to be part 3 of 4.4 notes, and this shouldn't be too bad. This really is going to actually kind of review some stuff we've already looked at, and that's going to be properties of logarithms. We definitely already have looked at these two right here, where log base b, and then if you're evaluating the same base right here, it's going to simplify to the exponent. Or if you have an exponent and the base is the same as your exponent log base, then it's going to default to this x right here. Now, we actually did already do these here. We just didn't point them out. But I've got some examples right here for common logs and natural logs. So this is not, this is not 4 different ones. These are all 4 the same. They're just showing it to you with the different type of logarithms. So common log, remember that's going to be base 10. So see what they're saying right here is 10 to the 0 power gives you 1. 10 to the 1 power gives you 10, right? Okay. Then 10 to the power of x would give you, well, 10 to the power of x, right? Okay. And then this one here, a little bit more complicated, and so I'm not going to go through that again. If you want to go back to video 1, I did kind of give a more explanation of how this defaults right here into that x right there. Okay. And then this is just the same thing with natural log, except natural log just has base e. So, e to the power of 0 is 1, e to the power of 1 is e. E to the power of x would give you e to the power of x, and then you've got your third one right here, the inverse property. Okay, so what we're going to do is we're going to take the shortcut by using some of these properties here to make life a little bit easier. Okay, so looking at this first one, once again, we want to do this without a calculator. So if you're looking at this first one right here, you probably know what the answer is. 10 to the power of 2 is going to give you 100. That's what the answer is. That is the answer. But just to kind of show you how you could use your properties, because I want to prove some of these properties to you. If you were to look at this, this is the same thing as log of 10 squared, right? 100 is the same thing as 10 squared. And so the base is understood as 10, so hence the answer is 2, right? So here, once again, so you're going to have base 10, right? So 10 to what power would give you 10 to the 7th? That's just going to be that exponent right there. It's just that 7 right there. Okay, so now we're using that one that I kind of referred to earlier, that I kind of gave a better explanation of earlier. We can kind of go through that again here. So if we say, if I don't know what this equals, I can just set it equal to x. And then if you remember your conversion is going to be a log base 10, and I take the x right here, and then it's equal to what that exponent is. Now that exponent's a little interesting, right? It's log of 33. Well, it has an understood base of 10 also, even though it's not written there. It's understood as 10. And so then that must be, x must be equal to 33 then right there. So that's what that would simplify into right there. And so typically the shortcut is you just take the value right there. That's the idea of going through these properties. Okay? But it is important to kind of, it's a property, but you want to have some type of grasp of it. Okay. And so on this next one, let's see, 87. So remember, that's the same thing as saying log base e of 1, right? So e to what power gives you 1? That would be 0, okay? So e to what power gives you e to the power of 6? That would just be 6. So that, and once again, the property is that it defaults to this power because the bases match, okay? 91 requires a little bit of some manipulation, okay? And so what we could do is you could rewrite that as natural log of e to the power of negative 6, right? So you could actually reciprocate that and make your exponent negative. Now look, they match. Natural log base understood as e, and then you're evaluating an e to the power of negative 6, and so it just defaults to that exponent right there. And there you go. And then here's another one that we kind of saw earlier, except it was with logs. So e raised to the natural log base e. So if those match, then it's just this value right here. It's 125. That's it. That's the answer. Here on 95, you got natural log understood base e of e to the power of 9x, so bases match. It's just going to simplify to this exponent right there, 9x. Don't try to solve it, it's just, that's it, it's just 9x. Okay? And then basically the same thing on 97 right here. Once again, very similar to number 93. They're just getting a little interesting with what it simplifies to, because we've been getting numbers, now you're actually getting some variables involved, and so this is just going to be 5x squared, and so that actually is what it simplifies to right there. That's it. And just to make sure we understand, I'm just following these properties right here. I think the first two are very easy to understand. The third one's not very hard either. It's the last one, it's number 4, that gives people a little bit more trouble. But this other stuff should kind of help you. You just need to remember your conversions to exponential form. This is just, if you convert it, this is just saying b to the power of 0 equals 1. This is just saying b to the power of 1 equals b, which makes sense. This is saying b to the power of x equals b to the power of x. Okay, yeah. So you're just taking the base and taking this as the exponents here, okay? So anyways, don't get too hung up on this. I know a lot of students have a tough time because they're like, man, there's words here. Well, it's just a notation that's helping us out. Alright, so I did have one left down here, and once again it's very similar to 93 and 97, so I have 10 raised to log, which has an understood base 10. So whenever those match, they just, boom, you're just left with what's up there, and so in this case it's square root of x, and that's it. So we just want you all to get comfortable with that, because we're going to be using some of these manipulations in other, in simplifying in other sections of this unit. Okay, so I only have one slide to go for this section. So here we go. Alright, so right here it says find each of the following using a calculator. Round 4 decimal places. Okay, so I do have my calculator, and you can put these in your, you should be able to do this in your cell phone calculator also. If you have the iPhone, just turn it sideways, and you should be able to do a log on there. Also, scientific calculators have all this stuff. You don't have to have a graphing calculator to do these, okay? Alright, so here we go. So, alright, pull this up, move this out of the way. So I have to use a calculator here because, well, let's think about what they're asking actually real quick. So what does this equal? So remember, it's base 10, so they're saying 10 to what power gives me 3? Well, that's interesting because I'm shrinking. I'm going from 10 down to 3. So this power is actually going to have to be, it's probably going to be less than, well, it's going to have to be less than 1, right? Because if 10 to the power of 1 is 10, 10 squared is 100, and so on. So if I'm shrinking to a 3, this would be some type of negative exponent. So like I said, back in the day, you'd have to look it up in an index, but since we have this calculator, it'll do it for us. So we're going to go ahead and press log 3, and let's see what we get. So 0.4771. So 0.4771. So 4 decimal places. There you go. And so yeah, that sounds about right. Let's see. Let's look at this next one. So once again, understood base 10. So it's saying 10 to what power gives me 532. Well, you know 10 squared gives you 100. 10 to the third power would give you 1,000, right? So it's got to be somewhere between 2 and 3. Our exponent's got to be somewhere between 2 and 3. So once again, the calculator is going to do the work for us. So let's see. Log of 532. And let's see. Yep, there you go. 2.7259. 2.7259. Alright, there we go. Okay, so let's see, what is this next one asking us? So let's see, 7 equal to y, right? So 10 to some power gives me -2. Something just seems a little off here, but okay, let's go ahead and see what happens. So let's see, log of -2. Huh. Error. Non-real answer. Okay. So yeah, that's what happened here. Um, is whenever you're saying that you're going to raise 10 to some power that's going to give you a negative result. Well, I'm not aware of a number that can do that. Okay. Um, so if I mean, think about this. If you have 10 to the power of negative 2, that doesn't cause it to be negative. That would actually cause it to become 1 over, 10 squared was 1 over 100. So that doesn't cause my result to become negative, even if my exponent were to be negative. Okay, and even if it were a, a decimal or whatever, that's it's just not going to work out. So we just have a problem right here, and so basically, when you're doing your homework or something, it might just say that you're out of the domain or whatever. Because if you remember, the domain has to be greater than 0. Okay, so it might say can't simplify or something to that effect. So, all right. So I got just a couple more down here, and so the only difference here is we're going to be using the ln. So just to kind of, once again, I just want to convert this to make sure, give you a little bit better understanding. So this is saying e to some power equals 2. Remember e is just about 2.7218, so on, so on, so on, okay? So, all right, so it's this irrational number, so something raised, that value raised to some power is going to give you 2. So it's probably just slightly less than 1. So let's find out. So let's see. Clear that out. So natural log, by the way, with this calculator, which you'll get to use on the exam, right here next to 4. So natural log of 2. Close that. Let's see. So 0.6931. So 0.6931. There we go. Okay, so then our next one right here, we'll set this equal to y, right? And so we're going to say, okay, e to some power is going to give me 809.3. So that's an interesting number they gave us. But our number is going to get, it's not going to be that big. It won't be a double digit or anything like that. But it'll probably be around 7 or something. I don't know. Let's find out. So let's see. Natural log of 809.3. Close it. Let's see. And let's see how close it was. I was off by a little bit. But anyways, I said somewhere around 7. So let's see. 6.6962. So we got to round that up to a 2. So you want to make sure you're putting this in right when you're doing your homework. So 6.6962. There you go. Okay. Last thing, and this will be something that we'll definitely have to use in our other sections. And so some of these calculators, you can actually go ahead and change the base of your log. So sometimes on some of these newer calculators, when you press log, it'll give you these boxes that you can actually fill in. But the calculators that we're going to be supplied with for the exam, it's going to default to a 10. And so you're not going to be able to change it. And so we have this change of base formula, and it works out quite nicely. What you do is, if your calculator can only do base 10, what you can do is you can take these two numbers and give them their own logs here, okay, and then divide them. So just as long as the bases are the same, it doesn't really matter what base you use, okay, just as long as they're the same. So you take the evaluated part right here and put it with some base, and then actually take the base, and that becomes part of the denominator's logarithm, what's being evaluated. So for example, this would be the same thing as doing log base. We'll just do 10, because that's what our calculator's defaulted to, of 100 divided by log base understood 10 of 4. So that's all I did. I just took those two parts right here and right here and rewrote it out with log base 10 right here. The other option you have with these calculators is you could have done base E. You could have done natural log of 100 over the natural log of 4. So I'll show you in the calculator because either way you're going to get the same result. So let's see, log of 100, I want to make sure you close that parentheses, divided by log, and so no mixing and matching, they got to have the same base. So they both have base 10, and so let's see what my answer is. So 3.3219, so 3.3219, so that's my answer. And just to kind of show you, if you do it with natural logs, it's the same thing. So natural log of 100, close it, divided by, let's see, natural log of 4, close it, and you get the same exact thing. Now I'll prove it to you though, because remember, what is this actually asking? This is really asking you 4 to what power equals 100, if you think back to what's being asked. So I'll go ahead and test that theory. So let's see, I'm going to do 4 caret, remember that caret key, and so I'm going to do 3.3219. It's not going to be perfect because we rounded, right? But it's going to be pretty close. It's probably be like 99 or something like that. So let's see. Yep, 99.996 is, whatever. So if you take 4 and its exponent is 3.3219, that's going to get you pretty close to 100. So that's what we're doing here, okay? So we got last one. And so, yeah, your base can be a decimal, it just can't be negative, okay? And so we're going to go ahead and convert this. So whichever one you want to use, whatever, log, natural log, whatever. So log is 17 over log of 0.1. Okay, so we'll go ahead and put that in the calculator, but just let's remember what they're asking. They're asking us basically 0.1, which actually 0.1 as a fraction is actually 1/10, right? So they're asking us basically 1/10 to what power would give you 17. So don't be surprised that our answer is going to come back negative, okay? Because 1/10, 0.1, same thing as 1/10. If you're going to take that, make that become the reciprocal, and then somehow turn that into 17, our answer is going to have to be negative. So let's go ahead and do that. That's out of the way. All right. So let's see, log of 17, make sure you close the parentheses, divided by log of 0.1, close that parentheses, and here we go. So there's that negative answer I was telling you about. So negative 1.2304. So negative 1.2304. And once again, if you wanted to, you could go ahead and raise 0.1 to that exponent and see what happens. You'd get pretty close to 17. Not exactly, because it's an estimate, but we would get close. Okay, so that's the end of part 3.